Hello, 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 everyone. Welcome to our webinar today. We're going to talk about OBS Studio, real-time streaming, and a deep dive into different streaming protocols, specifically contribution protocols of how you send your stream into the cloud, into streaming services. And obviously, this is self-serving. We're doing this as a way to stream content into Millicast, which is our real-time streaming product. Joining me today is Dan Coffey, who is my colleague and product manager on the Millicast product inside of Dolby. Hey, Dan, how are you doing?
Hey, Ryan. Good day. How are you?
Very good. This is an exciting topic. Obviously, we are both involved deeply on the product side of things within Dolby. And I was one of the co-founders of Millicast and have been with the company now for quite a few years, even through the acquisition of Dolby. And I recognize on today's webinar a ton of our old customers, some of them going way back to the beginning. And I think what's interesting about today's topic is this is a topic that relates to a variety of different use cases, everything from live auctions to remote production or remote contribution for real-time monitoring. I see we have a couple of esports users. And the interesting thing about all of these use cases is they can all benefit from the updates to all the protocols that are happening in the streaming industry. And what better way to do that than to actually explain how our technology works and how these protocols works with the world's most popular encoder, which is OBS Studio. And why is it so popular? Well, it's free. That's why. And it's also a software encoder that works on Mac, Linux, Windows. Everyone uses it, including 12-year-olds streaming to Twitch. Their game that they're playing on Steam.
It's not just software, right? Because it's open source, people have added support for the Apple hardware encoding, NVIDIA hardware encoding. So it is very well supported and very robust because it streams to so many platforms.
Exactly. And I think everyone here is probably pretty familiar with it. So I'm not going to bore you with the details, but we're going to talk about two main things today. One is the updates to the core OBS Studio project, which I think is quite critical to how you can use that with Millicast and real-time streaming workflows, updates with WebRTC and WIP, which is a contribution protocol, and also updates to both SRT and RTMP that I think is a good place to start. But with that in mind, Dan, why don't I turn it over to you and you can share some slides. I want to focus on workflows first, because I think that's the most important thing to focus on before we start diving into the nuances of the technology.
Yeah, absolutely. So I've got some slides prepared, and really what this is to talk about workflows of today and also a look towards where workflows are going. I will say that take this all with a grain of salt because, right, this is depending on your use case, you're going to have different requirements and different needs. But I thought let's walk through a few basic workflows so that we can kind of set the stage and have a shared understanding of what we're talking about, and then we can go forward. So I've got a few slides here, Ryan. And so the first one is kind of the typical workflow of today. And this is not specifically necessarily WebRTC, but generally how, live streaming workflows go. And so how it starts is you've got your camera or your video switcher. You've got that all connected in a local network using something like SDI, NDI, Simply 2110. And that ultimately feeds into a contribution encoder. And that contribution encoder sends a single high bitrate mezzanine style feed to the cloud where you hit an origin encoder, right? And so at that cloud origin, it starts to do multi-bitrate encoding. It generates what we call a distribution feed that's ready for consumption by end viewers, and that gets pushed into typically a CDN. With us in WebRTC, this is actually the Millicast CDN. And then all the way out of the cloud, right around the globe to actual users at home watching videos in their video players. So a very kind of simplistic look, but that's the workflow of, I don't know, what, the last 15, 20 years, Ryan?
Yeah, I think that the funny thing about what we're going to be talking about today is history repeats itself. And how it used to be 20 years ago is doing Flash, you would actually do the multi-bitrate encoding from the source. And we're going to talk about that in a bit. But we kind of moved to the Apple HLS world, typical live streaming world, what we call typical now. And you send one mezzanine, you do the transcoding in the cloud, and then you send what's known as an adaptive bitrate stream to viewers. So the viewers here on the right of the screen are all getting a adaptive bitrate depending on their device or their bitrate. So yeah, let's talk about the next workflow. This one I think is pretty common and something everyone on the stream is pretty familiar with.
Yeah, exactly. And so that's the single bitrate workflow. And so what we're doing is we're erasing this distribution encoder, and we're moving it on-prem, right? So you're starting, whether this is OBS, right, in the use case that we're talking about today, or some other hardware encoder in a rack, or a software encoder in a rack. This is where you get your uncompressed feed into the encoder. In an OBS, this would be your canvas. You do a single bitrate encoding, right? So you've got a compromise to make here. Instead of doing adaptive bitrate streaming, where depending on your device and the connection that you're on, you get the optimal streaming experience for you. You kind of compromise and say, okay, everybody's going to get 720p at 2 megabit, and that's just going to have to be good enough. And that means that your viewers who are on a mobile connection, they might not have the best experience. And viewers who are watching your stream on a TV, it's going to look a little bit compressed because you're looking at such a large image. And so we don't get some of the benefits of that adaptive bitrate.
But the benefit here is this is the early days of Millicast. When we first launched Millicast, what was Millicast? Well, we tried to leverage all the work put into WebRTC, which is pretty much open source by Google. People were using it for real-time communications. We're like, yeah, we like that. We like that real-time stuff, but let's do it for linear streaming. And we realized that every browser, billions and billions of browsers around the world, mobile browsers included, could be a decoder. And we're like, wow, this makes a lot of sense. And with Flash dying on the decoder side, we're like, well, we can just use every browser. And ultimately, that's what Millicast was, right? And with a single bitrate contribution for a lot of our remote monitoring, that's all they needed. For our live auction customers, if you're selling cattle in New Zealand, you've got a 1 megabit contribution anyway. So, okay, let's just send that. And that's good enough for people buying cattle halfway across the world, right? And so it really hit a lot of these use cases. And this was good enough. And back in the old days, in the beginning of Millicast, 4 or 5 years ago, we just had a single origin too. So we were doing this and you were delivering into our single POP, and then we're delivering from that single POP, regardless of where you were in the world, using WebRTC. But this quickly, as people realized the value of WebRTC, because they could access real-time streaming to all these billions of devices and web browsers, they're like, no, we want the features of live streaming. We want multi-bit rate. We want adaptive streaming inside of this exact same workflow with real-time. And that's what leads us into this next use case.
Yep. Yeah, and with this one, right, we're doing the same thing. We're taking the origin encode out of the cloud and we're moving it closer. And I mean, it's probably worth talking about some of the benefits of this, right? By doing that, you take out one leg of the chain. You also reduced your latency because there's not dual processing. You reduce compression because you're no longer sending a mezzanine feed in and then recompressing it for distribution. And that all those steps add latency, right? So essentially, you can spend a bit more time at your actual encoder, make your settings higher quality, and then when you pass it through, right, you send 3 different bit rates. So each of these arrows represents an RTMP stream or SRT. There's multiple ways that we can look at this. That feeds into the service. The way that you package those up informs the service, hey, these 3 renditions are adaptive bitrate, and in WebRTC lingo, we call this simulcast, right? But the behavior is adaptive bitrate streaming, so that the end clients get the same multi-bitrate adaptive bitrate behavior, where instead of the single 720p coming in, you get the benefits for the big TV of 1080p and the small phone at 360p. And so everybody watching the stream, no matter their network condition or their device, gets the optimal streaming experience.
Yeah, and notice that so far we've barely mentioned what the protocol is. We're just talking about what are you trying to do? Like, you're trying to send a single bit rate to everybody? Are you trying to send a single bit rate into the cloud and have the cloud transcode and deliver? Or in this case, hey, no, I want high, medium, and low, but I don't want to transcode in the cloud. I want to send it from my source encoder, in this case, OBS Studio or any other encoder, and I want all the benefit of adaptive bitrate streaming for the viewer, which in WebRTC is called Simulcast. And all these workflows are still real time. They still use Millicast. They still deliver WebRTC. It's just how you're contributing it. And what this kind of leads us into is a little bit of complexity. And the complexity is that every protocol is not created equal. So where has the industry been? Well, Flash, as you guys know, was the RTMP protocol, and that's why it's still so ubiquitous. But everyone thought RTMP would have died by now, and it hasn't. And what's complicated this, and the reason we actually delayed the webinar by a week, is because RTMP has a new life. And the new life is, hey, if you want to get multi-bitrate delivery to your end clients here, you don't have to send us 3 different streams. You can just send us 3 encodes inside the same bit stream. And that's the new thing that has just been launched with RTP Enhanced. And maybe you can expand on that, Dan.
Yeah, I mean, it's kind of exactly what you said. So the difference between these pictures is minimal, right? But there's a bit of efficiency in it. So instead of having 3 different RTMP streams come out and have to configure your encoder with different endpoints, I mean, there's room for human error. You actually have one RTMP that supports multiple tracks, right? So you can do multiple video tracks where you want to do adaptive bitrate, but you could also do multiple audio tracks for things such as multi-language. And you know, with us in Millicast, we've supported all these use cases by doing this for the last number of years, but now it's going to be possible by RTMP Enhanced version 2 of the spec supporting multiple video tracks to do this in a single RTMP connection. So it's just going to be a bit more efficient, a bit more elegant, and that is one of the changes coming to OBS, which to tie this all back together in the mainline branch of OBS, this will soon be possible.
So let's switch it up a bit. Let's get away from the workflows and let's actually talk about, once again, the use cases, but in the context of protocols. So a lot of this is going to tell the story of Millicast as a startup and how it's evolved. And everything that Dan showed, this is adding a little bit of complexity. Everything here, capture and broadcast and encode, is happening at the edge. What does the edge mean? Well, you're an auction company. Well, you're doing it where you have the camera connected and you're streaming from there, and you have a local internet connection. That could be 5G or that could be wired or whatever, and you're streaming into the internet, right? So you can see here there's an OBS logo. And when we first started Millicast, we realized what's the most popular way to make Millicast popular as a real-time streaming CDN. It was the first of its kind to use WebRTC. Well, we realized what we need to do is, why don't we add WebRTC to OBS Studio, and we can make sure we can do a real-time workflow end-to-end. So because OBS Studio is an open source project, we took OBS Studio and we forked it into its own version that had WebRTC inside of it. What did that allow you to do? Well, it allowed you to use WebRTC as a super real-time streaming protocol and deliver that into Millicast, and then we could send it over. The cool thing about our version of OBS WebRTC is that if I come in here and I come to settings, you can see there's a WebRTC option. And what we could do is we could also use Simulcast. So what is that doing? Well, that's creating a high, medium, and low version of the encode and sending up from the source all the way to the end viewers through the Millicast CDN. And how that works is Millicast didn't touch your encode at the source. You would send us these 3 versions inside of WebRTC into us. We would scale it around the world and we would deliver it to viewers in the browser, on the mobile device, inside of our different client-side SDKs. That was a really great way to use the value of WebRTC as a real-time contribution protocol, but add this capability of WebRTC, which is called Simulcast, from start to finish.
Yeah.
Well, the industry started to be like, okay, that's kind of a good idea. Like, yes, it's a bit of a lossy protocol and it's not great for, tier 1 contribution, but it's a great way to get my encodes out into the world and deliver them to the browser. So people could use that, once again, auctions, remote monitoring, esports, a whole bunch of different workflows. Well, it became so popular that my co-founder and the CTO of Millicast, Sergio, wrote a spec around this called WIP. And WIP was a way to standardize the communication in between an encoder and any service that could support WebRTC. It just standardizes the signaling, the language in between the encoder and the CDN, right? And it was called WebRTC HTTP Ingest Protocol. WIP is still WebRTC. You can use it with Simulcast or without. It doesn't matter. But the big thing here is that we have WebRTC as an option. Funnily enough, that does not use WIP. But now inside the core version of OBS Studio, which is this version here, I have both of them installed on my Mac, we now have WIP as an option inside the interface. What's so important about this is that means that you can now send a WebRTC to any service, not just Millicast. There are others out there too. The only big difference here is that you can put in your WIP server, which is available inside your Millicast dashboard, and we can show that. You can put in your publishing token, but you'll notice what's missing here is you're not currently able to simulcast. You can only send a single bitrate stream. So whatever you choose as your output in here, in this case, I've got 5 megabit per second. I think I've got this set to 1080p. You're only going to get one stream to all end viewers with WIP, unless you can do some transcoding in the cloud to add that simulcast capability. And I
Yeah,
hope that makes sense. That was one of the big things I wanted to clarify as we kind of talk about these different workflows.
yeah, completely, Ryan. And it's kind of funny. We almost worked backwards in Millicast, right? We just launched our cloud transcoding option to do this origin transcode because there are very valid use cases where you're coming out of a studio with limited uplink and you can only send one feed. So there are plenty of cases where you actually do want to do the encoding in the cloud. But more and more we see as bandwidth becomes less of a restriction, these edge cases moving to the edge. And I like to call this the power of pass through because it's what you said. We take the frames as they come in and package them up as that adaptive bitrate and send them all the way through so that you get the best viewing experience and there's no re-encoding of the content, right? And especially as we look at codecs that become harder and more complex, such as AV1 being the up and coming codec of the future, right? Being able to leverage hardware-based encoding in your server, right? That is going to make it much more economical to be able to scale your streams and then leverage our pass-through mode so that you get the highest quality at the lowest latency.
Yeah, and we haven't even started to talk about codecs yet because now you just opened Pandora's box. But
I did.
I want this webinar to be very interactive, and Nick has a great question here. He asks, doesn't WebRTC only support H.264 with limited profiles? Funnily enough, like WebRTC itself is agnostic to the protocol you wrap inside or the codec that you wrap inside of it, both the audio and the video codec. The important thing to note is you'll see here with WebRTC as a protocol, we actually support a variety of things: H.264, H.265, VP8, VP9, AV1. And then similarly, this doesn't even mention the audio codecs. You can put AAC potentially inside of WebRTC, but the problem is that AAC decode doesn't work by default inside the native browser. So in that case, you're better off sending Opus, which is what we do. And similarly with RTMP, if you send us AAC, the only transcoding we did in our early days was actually just the audio codec. We would change that from AAC to Opus so we could send that to browsers and it would natively play back. So if we come back into the version of OBS, this is the Millicast version of OBS, which is OBS Studio. And it says CoSmo Software because that was our parent company before we got acquired. But you'll see here we have the ability to select different different codecs. And we can actually already do AV1. In fact, we have people using AV1 in streaming environments. It's just you want to kind of usually use H.264 or a codec that will get you the widest device reach. But if you have a closed ecosystem, we have someone developing like a set-top box use case right now for replace a multicast network. They want to do AV1 because it can give them so much better efficiency with the bitrate and the codec quality than they can get potentially with H.264. But in answer to your question, Nick, WebRTC can do a lot of things, and you're not quite restricted. However, you'll notice here inside the advanced settings, the simulcast ability is only available with these two codecs in our version. And the other part, to add more complexity, is you are limited, I think, inside of OBS Studio. I personally haven't tested using other codecs inside of the WIP integration inside of Core OBS, but
yeah, it makes a recommendation for you for codec. Just to put a little bit of a bit more detail in there, Nick, too, like WebRTC, like Orion said, it's really about your playback environment is where you run into compatibility issues. And AV1 is such a complex protocol that if you're using a software decoder, it can do things like drain your battery. Not all devices can even have a software decoder built into it. The new iPhones just implemented, or the previous generation now that the 16 is out, actually implemented a hardware decoder for AV1. But with regard to H.264, it's actually not limited on profiles. The limit is B frames, and these are bidirectional frames in the actual H.264 stream. So it looks ahead and looks behind the previous frames to put together the picture in between the iframes where you get the entire picture. Now, we're not going to get into the details of video encoding. We can have another webinar on that another time. But what you really need to do, you can support a high profile, which means more complex encoding algorithms being applied. You just need to remove B frames because the problem is when you're doing real time, there is no future to look ahead to, right? That frame doesn't exist yet. So it's only for more latent protocols do B frames actually work. So you can actually play it. It's a very funny stuttering effect. So if you ever play B frames in WebRTC, you'll know it as soon as you see it. But it is the case that you want to remove B frames, but you can still use high profiles for very high video quality.
Yeah, and it does bring up a good question because the core of this webinar was to talk about all the updates to OBS, some of them outside of our control, which is the core OBS Studio project. Some of it, what is our future plans for our fork of OBS? So
Yep.
Lucas has a good question here. He's like, with OBS 30 supporting WIP natively, does OBS WebRTC fork become obsolete? So the answer is yes, it will eventually, but it hasn't yet. And the reason for that is what you're seeing right here is the fact that Simulcast, which a lot of our customers currently use because they want to send high, medium, and low inside of the WebRTC stream inside of OBS, this feature is not supported by the core OBS. And if I switch over again to show you the WIP integration, you'll see I also don't have an option to select different video codecs like we do within our integration. And I don't know, Dan, if you know, I don't know the OBS's plans to actually add this to the core project.
Yeah, I believe that there's like always work in progress. It's the thing that we're watching to like that once that comes out and you can do the simulcast functionality with WIP in regular OBS, there's going to be diminishing returns on us continuing to maintain OBS. Of course, we want to hear our customers. So if you are our customer and you have a case for us keeping that going, we always want to hear from you. But I think the way that we look at it is, once OBS off the shelf is available, especially if you're one of these customers who ends up saying, hey, I've got my own creators or streamers who are like an auction company I've got my auctioneers who need to download the software. It's much easier to take the off-the-shelf version, right, which is maintained by the community, than necessarily our own fork, which we maintain. So I'd say we haven't made any final decisions on this, but again, it's diminishing returns once this feature is implemented by OBS.
Yeah, and we do still, like Dan mentioned, we do still publish the updated fork, usually a couple of weeks. It's usually within a month of it coming out. So that is something that we keep up on that integration, and it has the OBS Studio work in it. I do think eventually we will deprecate our fork, but we don't want to obviously remove features that a lot of our customers are already using. So there are a few more questions, but I do want to just show a few more things before we get too far off the path. Another thing I want to show, this is once again the core OBS project. One of our colleagues actually added a Millicast destination inside of here. So under Dolby Millicast, this is pretty much a streaming service provider. And inside of here, what it is, instead of having to put your WIP destination server, you just select Dolby Millicast now. And I think he updated this in June. So this has been in the core OBS project since June. Here you can select whether you want RTMP or RTMPS. If you choose either of these, it will auto select to what you have as a default inside of your account, or you can manually choose an ingest server that's close to you. And then here you can put in your stream key that you get from the Millicast dashboard. So this is a really easy way to just use Dolby Millicast inside of here to be able to send us a stream directly from inside of OBS.
Yeah. Ryan, I see a couple more questions. Maybe we can pick off from Arnaud. Yep. We got a question about VP9, right? As we do talk codecs here. So isn't VP9, better for the same bitrate compared to H.264? Yeah, I mean, short version is yes, but it comes down to that compatibility question, right? What is capable of doing the encoding for VP9? And then of course, browsers, all browsers support VP9 for playback. So yes, it's a more efficient, more modern codec, but often we see the bottleneck is actually on the encoder, and it depends on your workflow. So if you're going from a browser that supports VP9 encoding, it can be a great choice and a great alternative to H.264. But if you're using a more broadcast-centric workflow, such as a hardware encoder, it's more rare that they actually support the VP9 codec.
Exactly, and I think like Dan mentioned, if you look over here at the playback, we have a dozen client-side SDKs or something close to that. When you look at also different plugins that we have available, different devices we go to. The iPhone has added AV1 decode now, but it's still, you can't just send AV1 to your entire audience. So these are things that we're looking on from the product side is do we look at a multi-encode path potentially, where you can get the benefits of AV1 to people who have it available, but then be able to switch or fall back to H.264 to get that wide device support, right? It depends on what you're doing as a product. Inside of a closed ecosystem where you're delivering to a specific audience and you know which device they're on, say a set-top box, it's an easier question to answer. But this is a much more complicated thing to answer. It's not within the scope as a service provider. So it's really up to you guys to decide where we're at. And hopefully in the next few years, this won't be an issue. We'll have a lot of backwards compatibility with these different codecs.
Yeah. I got another question here, Ryan. I know we got other stuff we want to get to, but maybe we'll pick off a few of these and then continue on.
Yeah.
So we had a question from Hasim asking about experience some where WebRTC, where Simulcast was used, and it used way more CPU than RTMP. Primarily, this is because RTMP was using the GPU. So this is a great question, and it's got a very technical answer, and that this comes down to what is doing your encoding. So it may be the case that on your encoder, I'm going to assume that you're using OBS here, but maybe you're using something else. In OBS, it's important to configure that hardware encoder because hardware encoders are just so much more efficient than the software-based CPU encoders. So it sounds like the case probably is you were streaming on RTMP, it was using the hardware encoder, and then when you switched to WebRTC and turned on Simulcast, it was using a software-based encoder. And so of course, when you look at the difference between those two, on the software-based encoder, it's all being done on that CPU. And if you watch your CPU meter, you're going to go watch it spike up. And so yes, so again, as we look at the functionality inside of the core OBS, there's much more support for hardware-based codecs or encoders that has codec support. So it's a reason, one of the reasons why we are really very excited about this RTMP enhanced project, and we can get into a bit more of what that actually means because we haven't spent too much time on that just yet. And I know there was another question from Dan Zeitman on that topic as well. So I mean, Ryan, maybe we could detour over to that, right? So there's this new RTMP enhanced protocol. We talked about it a little bit, but maybe it's worth doing a little bit of show and tell on this one.
Absolutely. I'll reference this article. It's interesting, and I can post it here in the chat, I believe. So let's see. I'll put it in the chat window so you guys have it. It's a very interesting story about not just the technical evolution of RTMP and how it stayed alive, but also the business side of it. It looks like, I didn't know this, that Adobe had sold actually the rights to RTMP, and another company has taken that over and now evolved the protocol itself. And funnily enough, Twitch was a big driver of this because they needed this support. They have a ton of their users use OBS, and RTMP Enhanced has enabled what's it called, enhanced broadcasting, I think is the feature inside of Twitch that has kept us alive. Similarly, Twitch was a big reason that WIP made it into OBS Studio. There is another colleague of ours within the industry who really promoted WIP within Amazon that owns Twitch, and that ultimately, that influence made it back to OBS Studio. So that's a great thing for the evolution of WebRTC and WIP as a contribution protocol. But yeah, I'll switch it over to you, Dan, and you can show us a pre-recorded demo. I'm just going to be honest. We had our colleague Sergio, our CTO at Millicast, record this workflow because of the specific nature of the GPU that he was using on his Windows machine.
Yep, and also so what Dan referenced was an update to the RTMP specification that supports multi-track video. So there's this. Let me digress for a second. Go with me on this journey. So there's this new spec RTMP enhanced, which I have somewhere here. Here it is. So there's this RTMP enhanced specification. It's currently on version 2. And what this does is it breathes the new life into RTMP. So it adds things like multi-codec. It updates some of the things around metadata. It talks about enhanced audio. So there's a lot of things that RTMP was just stuck doing, and this specification breathed life into it. And so, Twitch has been on the forefront of pushing this forward. And so there's a whole article around this that we can talk about. They call it Enhanced Broadcasting Beta, but it's all about using this new specification for RTMP to do this multi-bit rate streaming that we talked about. So again, that's this picture here, where we're sending from OBS the high, medium, and low, or even more layers to do adaptive bitrate streaming. So this is what the actual specification looks like. We're not going to walk through this together, but just know that this exists. And we're in the middle of implementing this on the Millicast side. So what that looks like, this is the old one. I don't know if we're going to play that, but what this looks like I made it full screen, it's over here, is we have in our development environment, and we also have stream monitoring. It's what we're pointing out here. So you come into OBS when you have the proper encoding card, right? So in this case, we're using NVIDIA's AV1 codec, so hardware-based encoder in OBS, and the output mode is advanced. So we're sending to the dev environment for Millicast. We're putting in some details around the encoding, right? You can kind of tune the codec, and you can pick multiple bit rates. And so you can either say auto, go ahead and pick for me what the bit rates are, or you can uncheck that and go to a manual where you can set the actual bit rates. But once you start streaming, and this is in auto mode, the stream will come live in our ingest monitor. So if you're not familiar with our service, or if you're an old customer who hasn't logged into the dashboard recently, check it out because it's kind of cool. In the dashboard, we show you what the actual ingest into the service looks like. We give you the protocol that's being used, the bit rates, the codec, right? Often we see that bit B frame issue I talked about where B frames aren't removed. So we can actually identify that for you here. So again, just some niceties that we now have in the dashboard. So you can see from OBS in a single RTMP connection, we've got this multi-track approach. And you can see the different bit rates that are being sent with that. On the right side, you've got the video player showing this, and we'll move the mouse over here. And so here we go with, these are our media stats. You can see the current video resolution is 1920 by 1080. But if you go to the player, you can choose the different quality option that you want, right? When there are multiple tracks, you got 540 and 270. So when you click that, it seamlessly switches down to a lower bit rate and resolution, right? So you can see this number here change as we make that adjustment. And I mean, for me, this is revolutionary, right? The fact that we can do this with a hardware-based encoder such as AV1, right? With the ultimate quality, the lowest bit rate, a lot of benefits to AV1, which we'll talk about another time. But this is the promise of what multi-track RTMP is. And yes, we are adding this at the moment into the service itself. So really exciting. And if you happen to be at IBC and join the Dolby booth, we also showed this from a hardware encoder as well, this exact thing.
Yeah, and just a shout out to our partners there. It was, I just drew a blank, Dan. Tell me.
Yeah, it was NetInt, right? So NetInt has their Quadra card, and
exactly.
And with FFmpeg, I didn't talk about this, but FFmpeg is also picking up RTMP enhanced. It's currently in a branch. So it's not yet in mainline FFmpeg, but when you think about, again, and we're getting a little bit away from OBS, but the future of hardware encoders and manufacturers starting to support this multi-codec workflow, like a lot of them are built on top of FFmpeg. And so by FFmpeg picking up this RTMP enhanced specification, it'll be great that we will be able to easily see more RTMP enhanced. And of course, us at the royal we at Dolby will be ready as well. I've seen a question come up a couple times. Ryan, I'll just address it now. Will this be available later as a recording? Absolutely.
Yep. And I was about to go down the rabbit hole of talking about SVC, scalable video coding inside of these advanced codecs. I'm not going to do it because I've been shouting from the rooftops for years about it's time for SVC, these multi-bit rate or adaptive bit rate or simulcast, whatever. It's such a way of the past, but SVC is just a better way to do things. Mm-hmm. The problem, once again, is device support. So I wrote this article with help of some of my engineering buddies at Millicast. I'll put this in the chat if you guys do want to read and you want to be bored for a few minutes. This really talks about a lot of the great work. And if I go down here, there's a great presentation from Emily Vov talking about a lot of what you can do. And this is also a really critical thing is encryption is such a big part of it. And SVC, if you can never touch the actual bit stream, you can keep it encrypted from end to end. That's always been our vision at Millicast. That's always been what we think is the future of distributing anything across the internet. You can actually make sure that it doesn't get touched or decrypted. Current streaming workflows where you have to actually encode the video aren't secure, right? So you have to decrypt to be able to encode. So there's a lot of really interesting things in here if you guys want to be bored for a bit, but it may be outdated. I wrote this a couple of years ago.
Seeing the future all the way back then.
I just do it on the back of others. I am going to share your screen again, Dan. Why don't you
Yeah.
go ahead and show us the FFmpeg demo? Because I think you had actually triggered
Yeah.
or got this ready.
Yep.
So,
So
and then we can share the player URL so you guys can see RTP and RTMP enhanced working in. This is an FFmpeg
oh,
workflow.
it is, Ryan. Let me be honest for a second. This is not set up with the branch that I showed. This is a tease of the future to come, but it will show FFmpeg workflow today with the service. And so what I can do is I'll post the actual link into the chat, and then I'll pull up an FFmpeg command line, and we can walk through what this looks like today. So if you're not into coding, if you're not into command lines, this may just let it roll over, right? You can come back and explore this. But what I have is I have a Millicast loop. This is just a trailer we have for Millicast. And then I've got a few settings in here. So this is just a bash script that executes a command line for FFmpeg. Let me make this a little bigger just so we can make sure everybody can see it. So I've got the RTMP URL. If you're familiar with Millicast, you get that from our dashboard. So from our dashboard, you come in and you create a token, or essentially a channel. Within the channel, you can go to your publishing settings and get these URLs. So a couple things here, let's stop and point out, make this a little bit bigger so it's easier to see. You've got your RTMP publishing path, right? So this is what you would put into OBS if you're using a standard RTMP workflow. And for the multi-bit rate, we currently have a high, a medium, and a low bit rate setting. So this is how you tell the service, hey, package this up and make this adaptive bitrate or simulcast for delivery, right? We've got this really easy in the interface. If you're using FFmpeg, you need these as a single URL. So here you go. We make that really easy to do.
Yeah, and just to clarify, because I think you made the point, but I just want to make sure the audience gets it. Is this RTMP multi-bit rate right now? The way that we've done this over the last few years is these are different bit streams. So you send 3 different bit streams to one destination inside of Millicast, and we do the job of assembling it because we built that functionality. This is now going to become obsolete if you use RTMP enhanced, is you use one bit stream with the 3 encodes. And this is what Dan is showing.
Yep. So this is the workflow. I'm using FFmpeg here to represent my distribution encoder, and I'm going to make 3 different qualities. So let's come back to our FFmpeg script. I've got a few things. I'm removing B frames. That's important for WebRTC. Because I'm using a software-based encoder, I'm kind of throwing quality out the window by using 0 latency and a fast preset.
Okay, let's move this along, Dan. They came here for OBS,
I'm boring you already.
FFmpeg.
Okay. The key thing to look at here, right? I'm setting different sizes, right? So I'm taking one file, I'm encoding it 3 times, and I'm sending it to my RTMP URL. So with that said, let's go ahead and start the stream. Coming to you live, and if I flip over to the viewer, you should see it pick up in a second. And now.
And if you guys all refresh your browsers at home, if you pulled up that URL, you'll see the same stream. And if you go down to the bottom right corner, there's that little settings icon in Millicast Player, and now you can manually select the different bit rates.
Yes, and so if I click here, you can see I've got 1080, 540, and 360. I'll switch from 1080 to 360 because it's more dramatic quality change. But yeah, it's hard to see on the webinar, I'm sure. It kind of looks like a bunch of compressed mess no matter what. But that is the multi-bit rate workflow that we have today.
Yeah, so Mohammed has a good question here. And, I think Mohammed's focusing on, talking about Twitch and their enhanced broadcasting. We don't work for Twitch. We don't work for Amazon. We work for Dolby. So it's not an official answer. But he's asking about the transcoding pipeline or transcoding workflow, if they won't transcode anymore. I don't know that, actually. I think they added enhanced RTMP because it has other features. Some of it also is reducing the contribution buffer, which is something that we've actually implemented. By the way, we've done that not as part of enhanced RTMP. We've done that to just make RTMP more efficient by stripping out some of the buffer that you have on the contribution side. But no, I actually would assume that Twitch has kept their transcoding pipeline. I doubt that's changed. They just have added enhanced and RTMP to add other features. But I don't know. I haven't really read through the enhanced broadcast spec, so I don't want to comment. I don't know if you know, Dan.
Yeah. Well, yeah. Just to address the latency thing. So we've got this flag here in the dashboard which turns on and off the latency RTMP. This is exactly what Ryan said. It reduces the buffer from whatever the default is down to, I think we set it to 100 milliseconds or so. And let's address a question here that I don't know that got asked, but it's like, when do you use which protocol, right? When do you use WIP for contribution? When should you use RTMP? When should you use SRT? And so the short answer to that is it depends, like everything else in this industry. I like to say, use a contribution protocol. For contribution, RTMP is a great contribution protocol, and it's great because it works over the public internet very well. So it's got resilience built into it. It's meant to be distributed over the public internet, and it's the same thing with SRT. They're really wonderful contribution protocols. WebRTC and WIP certainly does as well. I'm not trying to knock that one at all. It's got resilience mechanisms built into it, and it's lower latency. So when you really want the ultimate speed, use WIP, right? That's absolutely going to be the fastest way in and out of a service. If you want a little bit more resilience, right, where you can tolerate a slightly higher delay, it might be a better choice to use RTMP or SRT, because again, you can bring the buffers down.
Now, while we're talking about transcoding in the context of Twitch, let's actually talk about transcoding in the cloud in the context of Millicast. So this wasn't going to be within the scope of today's webinar, but it does talk about a lot of people who maybe have a device at the edge that's just not powerful enough. They can maybe send a single bit rate stream out. That's not usually the case. Usually it's a bandwidth constraint that they don't have the upload bandwidth capabilities to send multi-bit rate contribution, right? In those cases, we had enough of these use cases that finally we're like, yes, let's go ahead and build a transcoder. So Dan, maybe talk about how we use transcoder, how it's available. And It is worth mentioning, this is a premium feature. It's because we're spinning up obviously a cloud instance to be able to do this workflow.
Yeah, so I'm going to go back to the pictures that I made, or we pulled up at the beginning of the show, right? Because it's much closer to this, right? So we're, from OBS, we can do a demo here. I'm using OBS as a contribution encoder, so I can send a higher bit rate, I can send higher quality, I can send H.265 for contribution. And then the distribution encoder, our cloud transcoder, is going to take that and compress it and make it for delivery to end devices. And so what that looks like is, we've got this new feature. It's still in beta, but it's very stable and being used in production. You can actually, pick which region to put it in, and you'll use this for ingest. I'll go back to my publishing token here and show you how to associate it. So what happens is in the publishing tab where you get your RTMP settings, you simply need to turn on transcoding, right? And again, premium feature, we have to enable this for you. And then you pick the transcoder to use. So this is my webinar demo transcoder. And now because that is running, I get a dedicated ingest point for Millicast, which is meant for contribution style encoding. And Ryan, if you buy me some time, I'll actually pull up OBS, and we can put this in and do a live demo.
Perfect. I'll buy you some time.
Unplanned live demo.
So, how does this all filter down to you guys using it? Well, I know we talked a lot. We threw around a lot of, acronyms and codecs and protocols. We try our best to keep our docs up to date, but there's a lot of update, and there's a lot of also old ways to do things that just become obsolete. So one of those is inside of our OBS and I'll share this doc with you guys in chat here so you have it. Is inside of this workflow, we talk a lot about these different protocols and you can look at them, and we don't even have enhanced RTMP here. You guys got a sneak peek of this new feature coming, but we did have an article that talks about multi-bitrate RTMP. And honestly, that was a separate plugin that you had to install to do these multi encodes and send those to different RTMP destinations. So we've talked about that. That becomes obsolete. So this Simulcast RTMP multi-bitrate part of this article, if you're currently using this, we would recommend you switching over to the enhanced RTMP, which would probably be a better way to do this going into the future, because it does it through a single bit rate, single bit stream, not multiple bit streams. So that's a better way to do it. The other thing we haven't talked about is SRT. So we became a part of the SRT Alliance at Dolby. You can now use SRT as a great contribution protocol. The thing with SRT, it was the protocol to kill RTMP, but yet here we are talking about RTMP. And funnily enough, this single bit stream multi-bit rate encode within a single bit stream is a feature that you can't currently do in SRT. And we actually talked to some of the team at IBC in Amsterdam last week about, will there be this kind of feature within SRT?
Yeah. Or an abuse of the multi-program right? Which is the one way you might be able to do it today. Anyway, I digress.
Yeah, exactly. So, so in that context, no promises there. We obviously don't work for High Vision, and we don't contribute to SRT that much. So I doubt our opinion matters. But use this article as a way to kind of stay up to date on differences between these different contribution protocols that we chatted about today. And now back to Dan. I've bought you enough time. Go for it.
Perfect. I got it running. Hopefully you saw me do that in the background, but I simply took the credentials out of the dashboard, put them into OBS. And so what's happening now is our cloud transcoder is generating the multiple bit rates here. And you can see if I click on the quality, there's actually quite a few layers in here. We have the ability to work with you on a customized ladder if you have special needs, like you only need one layer or multiple layers. We also support things like we can pass through the top layer. So anybody watching your 1080p can get the original quality, and we'll transcode down ladder. So a lot of advanced functionality I'm going to wave my hands at. But the question from Lucas came up about latency. And so I'll just let you be the judge, right? So I have over here the source, and here's the destination, or the playback, right? So this is end-to-end up into the cloud, transcoding, distribution as WebRTC, and then back to my browser side by side here. So let's take a screenshot. This is the way I always like to demonstrate this. We take the screenshot. I'll pull it over to this window. And so you can see, can I zoom in on this? It's not going to let me zoom in, but 45. It's definitely still sub-second, right? The stop. I wish I could zoom in. I'm sorry. The stopwatch arm is about 1 second away from that. And I would try to do the math live on the frame count, but I don't remember what I configured it at. I think it's a 60 frames per second counter and a 30 frames per second encoding. So I'm not going to try to do math on the fly in a webinar, but it's definitely sub-second.
Yeah, our transcoder only adds a few milliseconds. I think it's a few. How many frames is it?
1 to 2 frames.
1 to 2 frames of latency. So depending, are you doing 60 or 30 frames per second? You can kind of do the math on what the latency is.
Yep.
Perfect. I think another question talking about latency is what's the difference between low latency RTMP, so using that, reducing the buffer or removing the buffer, and using WIP or WebRTC, Dan?
Yeah. So really, I think that one of the biggest differences is that RTMP was created at a time when the internet was very kind of not nascent, but young, right? There was, we needed a way for real-time video to be highly resilient, right? And it's the same with SRT. We want really highly resilient protocols that are designed to go over the public internet. And so they, by default, have a very large buffer, right? Because distribution was able to take time. And as we get into these latency sensitive applications, every piece of the chain needs to become optimized to squeeze out milliseconds of latency savings. And so that's what we've done here. If we go turn on low latency RTMP, we're just reducing the buffer size at the RTMP portion down. Now, what's the difference with WIP? WIP comes in with a small buffer to start with. So there's a very, very, very small jitter buffer, which allows audio and video to be processed if packets come in out of order, but that's it. There is no other buffer in WIP as far as WebRTC goes. So it's already an even more reduced protocol. The other difference between WebRTC and RTMP is that WebRTC happens over UDP transport layer, which means it can be lossy. RTMP happens over TCP, which means that packets will be resent until they arrive.
Yeah, and that brings up another really good point. As I sit here, I was looking through the people who are attending the webinar, and I see our friends from the industry at Dejero. I never know if it's Dejero or Dejero. Anyway, it's my Spanish coming up. But Dejero is a fantastic contribution field encoder that can actually work across multiple that use case is super interesting as you look at other people in that space. You look at the more live streaming. I won't even mention their competitors, but there's a lot of these contribution encoders, and as you deploy these, a lot of these are used for what they call blue light. So this is like police or first responders, safety and security, hurricane response, looking at borders, and more these use cases need a real-time monitor. And you've got someone who is a police officer in the field, and good luck trying to get them to download an SRT decoder app inside of their but you can send it to a mobile browser, right, with WebRTC. And what's happening is those encoders are still fantastic encoders to do broadcast contribution protocols, but a parallel path to actually send a real-time WebRTC stream for real-time monitoring. And I've been trying to get the industry to adopt this for a long time. I'm like, look, the web browser is the world's most popular decoder. Like, that's what WebRTC enables. Stop talking to me about whether WebRTC is broadcast quality or not. I don't care. You're getting billions of decoders for free, absolutely for free. I'm sorry, I'm going to get off my
high compatibility. Absolutely, Ryan. I'm with you.
And look, I come from the broadcast and streaming world. I get it. It's taken me a long time to try to convince the world that this is a technology worth doing.
Well, I mean,
let me finish this point real quick, Dan. And I'll promise I'll get off my soapbox, is we have actually added a feature to help with these workflows, which is send us a WebRTC stream or a super low latency stream, and then we can restream it to another destination too. So we have added a restream feature, shameless plug. Once again, if you are sending us WebRTC, then maybe it's not a contribution, broadcast contribution protocol or resiliency. But anyway, and part of that too is that we're also seeing other devices like DJI has added a WIP integration into their, what do they call those things? The base, the DJI base dock, whatever it's called. So people can actually remote control drones from halfway across the world. Like, these are cool use cases. And I think WebRTC has a place for those kind of real-time monitoring or real-time streaming use cases.
Yeah, absolutely. It's that interactive latency. While you were talking, Brian, I did pull up the RTMP restream. Currently only supported with RTMP in, but we are working on multiple protocols in and out actively. So this is out already for a single for RTMP in, and we'll soon support multiple protocols. Yeah, and on the conversation of compatibility, right? You said you get all these browsers for free, and there's this whole push and pull of what do we do with browsers who can't handle, or devices who can't handle AV1 but can handle H.264. So another thing that we're working on, kind of cooking up in the background, is that compatibility element where you can send both AV1 and H.264. And the way that our media server is going to work is that it'll recognize the device, figure out what its capabilities are, and then pick the appropriate codec. So you can have a compatibility stream of H.264, but also take a step towards the future where you can also pass AV1. Of course, we're still back to the problem of, okay, what can do the encoding? But as a forward-facing low latency service, we are absolutely thinking about all these workflows and how we will work with partners to make these things possible.
And speaking of workflows, Mohammed sent another great question about esports, and it's a great place. We have our friends at Maestro that, pretty much building a, Twitch competitor, and as much as you can go monetize your own stream, and they're very interested in a lot of these more unique workflows. I think one of the really interesting ones is, before Millicast, I was involved in another remote production workflow using WebRTC to build a mixer into the browser, right? And that's become quite a popular. There's quite a few of those companies. And then you've got the webinar platforms like Livestorm and StreamYard and all that are all using WebRTC for mixing. But within the context of OBS, that is another place where OBS, I heard a rumor, and I think I saw it in one of the OBS forums, that I think you guys might have heard of a product called OBS Ninja. Here, let me switch. So OBS Ninja became Video Ninja, and it allows you to grab a WebRTC source. And if you come into sources, you can come in here and you can pull in, like a browser window that will have a WebRTC, and you can use that as a source inside of OBS, right, to do your mixing inside of the studio. So you come in, you mix your things, and hey, I have a guest from halfway across the world who is coming in right now. Imagine you could actually do that, and this is a web source coming off of a WebRTC service. So
could be Millicast.
It could be Millicast, or there are other WebRTC services out there. You can go build your own too, like with open source WebRTC servers. Good luck scaling it, but we tried. It took us years to do it. But that's a really cool project, is how can we pull in, and what I think of, where does it replace legacy workflows? I'm sure you guys still see broadcasters who pull up Skype TX. You see it on CNN or you see it on BBC. Here's a dedicated 1RU unit that costs you $25,000 to pull in Skype. Like what are we doing, guys? Like you can pull in a much better quality feed with WebRTC these days than you can with any kind of a expensive workflow. So in a workflow like this, how can we build a web decoder that you can use as an SDI source inside of broadcast workflows? Good luck getting, the Kardashians or Taylor Swift to come onto an interview using, a professional encoding workflow to send her feed from her home, when she can just pull up her browser and send a pretty good quality broadcast stream, either in OBS or in a web browser to do it. So I think WEP, which we also were the people behind WEP as well as WIP and wrote both the standards, is web source inside of OBS. I would love to see that. So go, lobby your congressman and your OBS developers, and let's get WEP inside of OBS as a source instead of pulling in this kind of hacky side, source from. But I do love the Video Ninja project, so I'm not gonna. That's originally what gave me the idea about this. So
yeah. Well, Ryan, another thing, I don't think we can talk publicly about the actual vendor, but there's a vendor who has that workflow, and I think this was your idea originally too, to broadcast from a browser and then have a WebRTC decoder that can receive WIP and turn it into SDI for an actual broadcast workflow. So look for that coming soon.
Well, I do think we can talk about it. So because they were the first, so it was Osprey Video. They were the first. Osprey uses GStreamer inside of their product, and GStreamer was one of the first to add WIP integration. So they added it into their streaming encoder. And then I told them, because so many of these encoder companies create specific application-specific contribution encoders and then application-specific broadcast decoders, right? So think of SRT, or think of like even NDI, or all these different workflows. Is yes, there's an opportunity there to use a WEP source and then output that to SDI output for more professional tier 1 studios who need some kind of a source remotely. So yeah, I don't know if that will happen, but all these shows, NAB and IBC, and a lot of streaming shows that we go to, at least once or twice we get people needing this workflow. So it's an important, thing to look at.
Yeah. All right, we got a few minutes left. Should we pick off a couple more questions?
Yeah, absolutely.
We got another question from Lucas about multi-source streaming. So another feature of the platform, if I can not fat finger this, we have our live demo running all the time. And so as it comes up, this is our multi-view feature where you can click and you can choose your own adventure, right, on what you want to actually watch. This is highly configurable. This is just our example of how you can use it, right? You can do a 4-up, you can do the side-by-side. And the way that it works is the big tile is adaptive bitrate, and all the small tiles are the lowest quality bitrate that we have coming into the service, right? That's done by design. You can do this differently in your own application if you want to, but Lucas, the way that I understand your question is, when you're doing this, can you do multi-bit rate on this as well, where you do edge path, you encode in an encoder in your data center and you pass multiple bit rate through? The answer is yes, and I want to show this in the dashboard because we actually made a feature to make this even easier. So if I come back here to the dashboard, I'm going to turn off transcoding because it doesn't work with that. And I'm going to go to my multi-source builder. And so this is a tool. All this tool does is modify URLs to make exactly what you're describing easy, but you simply add a source, and this is my main source, so I'll create that. I'm going to just say, hey, it's got 3 layers, high, medium, low, and then for camera 2, I'm going to do the same thing. I'll add 2 layers, and then I'll add cam 3, right? I assume this is what you mean. If not, let us know in chat. But if I add my layers now, I can go back here and I can simply say export, and boom, I've got all of the URLs, right? This is super complex, easy to mess up, and that's why we made this tool. But for your main encoder, right, here's your endpoint. It's got all of the configuration. We call them publishing parameters. They're in our documentation. But you've got the ability to configure these URLs very easily. And now it's a copy-paste operation. You can email this to somebody who's actually doing your operations. So the answer is yes, if I've understood your question correctly.
Very cool. And I just saw Randall posted this G-Neural Nets live to air. I will definitely take a look at this. That is a pretty cool tool. Definitely check that out. And then Hasim's asking, with the Restream endpoint added, I think you just asked that one. Dan Zeitman asked a question about Apple Spatial Video. Well, good luck trying to get WebRTC to work on an Apple Vision headset. Like, I think there's currently we don't output to HLS. That's not part of kind of the Millicast. There's plenty of HLS streaming services. And that's not something we do. However, as far as HEVC, we do have HEVC workflows. So speaking of video codecs again, we actually have customers in the remote production space, like in the Hollywood remote production space, who are doing remote post-production with, DaVinci Resolve or whatever, and they need to actually honor our super high codec. So in those use cases, they're using our Apple TV SDK to build an Apple TV app that can do an end-to-end HEVC workflow. So that is possible in our platform. Once again, the reason people aren't using H.265 and specifically HEVC is just the device ecosystem is so fragmented that they can't get 100%, efficiency of that playback. So that's why there's not a huge adoption within our streaming customers right now.
Yeah. All right. Let me pick up the last couple. So you started on the question by Hasim about the Restream endpoint. To answer the question about will a single ingest exist? Yes. So you would ingest into Millicast the way you do today, and any endpoint that you add, I think we can add up to 10 distribution endpoints, we will send RTMP out, which is different than what we normally do. And so there's another question from Lucas again, which I can no longer click on, but Lucas, you asked now I could use RTMP side by side with WebRTC. The answer is yes, but I want to clarify that what we do when you send us RTMP into the service, we actually send WebRTC out. So we take that and we repackage it as WebRTC. We don't send RTMP to end viewers unless you use this Restream feature, which is meant for distribution to another platform or service provider.
No, Lucas has been around for a while. He's one of our old customers. I think he knows that. So cool. Yeah, but the cool thing about the multi-viewer is we don't care about the streaming contribution protocol. So you can send us whatever, and we work our magic to make sure that gets into a WebRTC playback inside of that client, right? And what we did with the builder is we did that on purpose to just make it easy. It was so complex to do that yourself that we've added a lot of that logic to just make it so much simpler to do. And
I showed RTMP as the protocol, but you can just as easily pick WIP or SRT, and now you'll get the same thing. So you can have multiple layers. And if you export just this layer, here's your WIP endpoints, right? And your bearer token.
With that, Dan, hopefully we didn't just confuse everyone even more so.
I'm sure we did,
to clarify everything.
It'll lead to more conversations. And Ryan, where did the hour go? I mean, it's just so fun to present with you. So thanks for putting this together.
Yeah, no, not at all. Well, of course, yeah, same here. That was definitely a lot of fun. And thanks to all of you for attending. Send us any more questions you have, reach out to us. And yeah, thanks for attending. We'll send the recording the next couple of days. See ya.